Okay, is it carrying? Yes, it is. Okay, it's recording. All right, so this section is about multiplying fractions, and it's really pretty easy. And I'm doing like I told you guys, we're going to go with big 1 and big 2 because they're essentially the same thing. Now, the first thing I want you to know is that if you ever have to change a whole number, let's say 2 into a fraction, all you do is put a 1 underneath it. If I want to change 17 to a fraction, all I do is put a 1 underneath it. Any number that you want to change into a fraction, just put that number as the numerator. That's the number that goes on top. Draw a line and put a 1 underneath it. And it's a fraction. Now, how do I know this works? 2 over 1? How do I know that equals 2? Well, raise your hand if you remember what that line means in a fraction. A couple of you do. It means divided by. What's 2 divided by 1 equal? 2. What's 17 divided by 1 equal? 17. So, anytime you need to turn a whole number into a fraction, you just put a 1 underneath it. So I'm going to do this first example here. Before I go over in much detail, I'm just going to go ahead and write it down. It looks like I got 6 times 2/3. Okay? Now, to multiply a fraction by a whole number, you need to change the whole number into a fraction. And I just taught you that. How do we change 6 into a fraction? So I'm going to just change it to 6 over 1 times 2/3. Okay? Now, here's the cool part. I don't need to find the common denominator. I just need to do the multiplication. What is 6 times 2 equal? What is 1 times 3 equal? There you go. Now, this, I can see the students already noticed one thing. We're really not done, because another way of saying that is what's 12 divided by 3? 4. So now we're done. Now 12 over 3 is the same as 4, but that's called a, what, improper fraction. Okay? So that's all you do. You just change the whole number into a fraction and multiply straight across. How about this? 7 times, how about 1/4? Equals, well, change the 7 into a fraction times 1/4. Now what? I just multiply straight across. 7 times 1 is, 4 times 1 is, okay? Now then we have an improper fraction. And so I would ask myself, how many times does 4 fit into 7? Once. What's left over? So 7 times 1/4 equals 1 3/4. Right? So let's look at the example they gave here. And the model it. Here they've got a 6 times 2/3. And I think I can, well, I won't worry about cutting it out, but look how they represented it. They drew a block of 3 6 times. And then out of those 3 blocks, how many did they shade in each one? 2. And that's the numerator. That's 6 times 2/3. So the shaded area in each one of these represents the 2/3. Okay? So, and so I can count how many are shaded. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And the denominator, the 3 doesn't change. It's 12 over 3. What is 12 over 3 equal? 4. So that's one way to model it. Another way to do it is using what they call the associative property, and we talked about that before. 6 times 2/3 is the same as 6 times, and then in parentheses, 2 times 1/3. And so you're going to end up with the same answer of 4. I don't know, I actually think that kind of makes it a little more confusing. So I'm not worried about to convince me in the sense that I don't want you to use repeated addition, which is kind of what they're doing here. But I do want you to find the answer for 10 times 3/5 equals. So I'm going to stick here. This noble, 10 times 3/5. What's the first thing I do? Well, actually I'm going to change 10 into a fraction times 3 over 5. And then you would see, I do kind of jumping ahead, but 10 times 3 is what? And then 1 times 5 is what? And on this noble, keep it coming here. What does that line right there represent? Yeah, division. So what's 3 divided by 5 equal? 6. So the answer to the convince me is 6. All right, I got to practice that with the one I crossed out. Number 2, it says find 2 times 3/5 and shade the model to help. So let's take a look at that for a moment here. And let's do some shading. All right, so here's 2 blocks, and there's 5 in each one, and the numerator is 3. So how many blocks do you think I'm going to shade? Shade 3 in each one. Okay, so let me show you a couple things here for that one. Let's do 2 times 3/5. So I'm going to change the 2 into a fraction times 3/5 times 3/5. And 2 times 3 is 6, and 1 times 5 is 5. That's an improper fraction. So that's going to be 1 and what? 1/5. 1/5. Okay. Now, let's go back to number 2, the model that they had us fill out. What's the denominator in the fraction? In that fraction, what's the denominator? 5. So I can just go ahead and put 5. And how many of those blocks are shaded? And all of them. Altogether, how many are shaded? 6. Look at that. We have the same thing right here. Okay. All right, let's look at number 3 here. I did that one for you already. It says find 3 times 2/3 using repeated addition. What's going to be 3 times 2/3 equals 2/3 plus 2/3 plus 2/3 plus 2/3 3 times. In 4, I already did it. It says find 6 times 3/4 using the associative property. So I wrote 6 times 3/4 equals, and I put 6 times 3 times 1/4. out for you, looking at number 5. It's 6 times 3 quarters. And so I put 3 quarters plus 3 quarters and didn't fill out the rest of these, but I could have, I just didn't. And then you're going to end up with 9 over 2 or 4 and 1/2. This would be 6 times 3. Number 6, again I filled it out for you. 16 times 3/8. And they've got 16 times 3 times 1/8. So notice what they're doing in each one of these, depending on the method that you use. It's the whole number times the numerator, which gives us the numerator on top. Look at this one. It's going to be 16 times 3, which is what? 48. Look at this one. 500 times 2, that's going to be 1,000. And then it's going to be 1,000 over 5 because the denominator stays the same in each one of these. We start with 3 quarters, so 4 is the denominator. It stays the same. And 16 times 3/8, 8 is the denominator. That doesn't change. 500 times 2/5, what's the denominator? The 5th, or the 5 rather, doesn't change. Nice? Or not? But that's one way to look at it. Let's do a couple of these. Look at number 10. All right, 9 times 2/3 equals, we'll stick here, Mr. Canisa. What's the first thing I do? Very first thing I taught you would be to change what? Yeah, so we can rewrite this as 9 over 1 times 2/3. Okay, Mr. Canisa. Now I'm just going to multiply straight across. What's 9 times 2? And what's 1 times 3? How many times does 3 go into 18? So the answer to number 10 is 6. Number 13, let's look at that one. 50 points. 900 times 2/3 equals, Mr. Gisa. So how do I rewrite this? What? 900 over 1. Okay, what's 900 times 2? Yeah, 1,800. What's 1 times 3? It's too hard. I saw the smoke coming in my ears here for a moment. All right, so, you guys, some of you may remember the shortcuts that I talked about. Gosh, 1,800 divided by 3? Oh my gosh, that's a lot. But how about if I just ask myself, what's 18 divided by 3? Yeah, it's 6. So I can put a 6, but then don't forget the 2 zeros, so it's 600. So the answer to number 13 is 600. All right, I think you guys can do this. Number 11? All right, let's take a look at it. Number 11, 300 times 1/2. All right, Mr. Graham, what's the first thing I do? 300 over 1 times 1/2. Okay, what's 1 times 300? What's 1 times 2? What is 300 divided by 2? Okay. All right. Let's see here. Let's look at the problem solving. Explain how you would find 36 times 3 quarters mentally. Let's see what you guys come up with here. There's 17 lions spend about 5/6 of the day sleeping. Wow. How many hours a day does a lion sleep? How many hours are a day? So it's going to be what? 5/6 times what? Okay. And actually, I probably should put 24 times 5/6, but you can see why we're doing 8/1 and 8/2, because they're the same thing. A fraction times a whole number, or a whole number times a fraction. The rating of Marsh's weight is about 1/3 of the weight on Earth. If Helena weighs 96 pounds on Earth, how many pounds would she weigh on Mars? You can do that one. Number 19, Barbie's making fruit salad. For each bowl of fruit salad, it needs 3/4 of a cup of grapes. How many cups of grapes will we use? It makes 24 bowls of fruit salad. Well, that's going to be 24 times what? 3/4. Number 20, do you think the difference between 1.4 and 0.95 is less than 1 or greater than 1? Interesting. You can do that one. Number 21, had a multiplication expression that shows 10 to the 6th power. So that's going back a few months. Let me ask you a question. Who remembers what 10 to the 1st power equals? Mr. Button. There's points. You should know this. Mr. Anderson. What's 10 to the 2nd? Oh, look. Mr. 10 to the 2nd. Or 10 squared. Mr. Williams, what? Erase points. Miss Maldonado. 10 cubed equals what? Mr. Williams. 1,000. You guys should see the pattern by now. Now, last one more. 10 to the 4th equals what? Mr. Delgado. 10,000. Okay, you guys should know those. So it says, this is, number 21, a multiplication expression shows 10 to the 6th. I think they're asking, maybe the answer would be 10 to the 6th, so you have to figure out what 10 to the 6th is, and then do a multiplication problem for that. We'll see what people come up with. Number 22, table shows, number miles, each person ran, more, I can do that. 23 and 24, I'm actually not going to worry about those, cross those out. Can I round it? Oh, darn it. Can I figure out? Oh, wait, is this still recording? Oh. Yes, good. Of course, it's a long recording. So we're jumping into 8-2, and we're trying to carefully move this up. do. Okay, so like I said, that convinced me I'm not worried about. Let's see here, another example. This is 5 3/4 times 2. And that's another way to get it, divide 2 into 4 equal parts. And so 3/4 times 2 is 3/2 or 1 1/2. Right? That's exactly what I was going to look at. So I want to explain what the product of 4 times 2 thirds is the same as the product of 2 thirds times 4. I mentioned that very early on when I was talking about this. And when it comes to multiplication, 2 times 3 is the same thing as 3 times 2. So in the phrase that the order of the factors does not change the product. And the product is another name for answer. And the factors would be 2 and 3 or 3 and 2. Question? Are you talking about 8-2 or 8-1? Oh, interesting. Okay. Well, then we're not going to So I guess this version I'm looking at is somehow different than what you guys have. Okay. And then practice find each product. It says draw models to help. You don't have to draw any models, but you can do 5, 6, and 7. And then the problem solving. I answered number 8. It says Janice said that when you multiply a fraction less than 1 by a non-zero whole number, the product is always less than the whole number in your brain. And that's kind of a mouthful, and you got to kind of think about it, but I wrote it down for you. The answer is yes, because you're finding part of the whole. So anytime you multiply a whole number by a fraction, and that fraction is less than 1, it's going to be less than what you're multiplying by. Number 9, scientists wants to find out how the properties of water change when salt is met. Yeah, I'm not going to that one. Cross that one. Shanna attends school for 1 week longer than 3/4 of the year. How many weeks in school does Shanna attend school? So to give you some information here that you need to answer that question, and that's there's 52 weeks in a year. So it's going to be 52 times what? 3/4. Number 11, Gina has 48 stickers. 3 of the stickers have pictures of flowers, and 1/8 of the stickers